Hello everyone! In this video we are going to use Jamovi to help us apply proportions to the central limit theorem. So if you remember back when we were dealing with binomial distributions, if we got the number of successes and failures to be at least about 15, the distribution that it would produce looked a lot like a normal distribution. And so at this point, we're going to show you how we can actually make that transition and use proportions inside of the central limit theorem to help us out. Okay, so what we're going to do is let's go ahead and extract some information from our problem, and then we'll see how we can use the normal distribution to help us answer these basic questions that we have. Okay, so first things first, let's go up to our analyses and let's open up a R editor real quick. Let's go ahead and remove some unnecessary pieces. We'll go to the gear and we're going to go to show our code and output. Okay, so let's go ahead and figure out what is our true proportion that we are dealing with. Now it gives it to us right at the beginning. She knows that the true proportion of people doing these competitions that have more experience than she does is actually 23%. So real quick, Jocelyn, she's entering into this cooking competition. And she knows that at these competitions, the true proportion of people who have more experience than she has is 23%. And then she knows that this particular competition, the sample size at n is 133. So 133 random people from like all of the cookers or chefs who enter into these competitions. 23% of them have more experience than she does, and there's 133 who are in this particular competition. Okay, so because we have these, we need to determine our standard error. Now remember that when we dealt with the standard error before, when we were dealing with means, the standard error calculation was just that sigma divided by the square root of n. Square root of n. That's how we found our standard error. But if we're trying to find the standard error when we are dealing with proportions, it's actually slightly different. This one is the square root of pi times 1 minus pi and divided by n. And that will actually provide us the standard error that we need. Before we do that, though, we should probably check to make sure that we have at least 15 successes and 15 failures. And the way that we can do this is we can just do pi times n. That'll give us the number of successes or number of people we think have more experience than Jocelyn. And 1 minus pi times n. And that is the number of people who we think have less experience than her, or how many we expect to see. And as long as those two are over 15, then we are good to go. So let's go ahead and run this real quick. We'll go ahead and click on our green arrow. And we have 30 people that we expect to have more experience than Jocelyn, 100 people who have less. So we're doing great. We have well met our requirements, and this distribution is going to be approximately normal. And we have our standard error as well. At this point, we're ready to ask this next question. What is the probability that more than 32 participants have more experience than she does? Okay, so what we can do is we can go and let's just type out more experience. And the number of people who we're saying what's the probability that we have more than is 32. Now, if we want to know what the sample proportion is, remember we can just take those, how many we're interested in, this 32 or more experience, and we can divide it by the sample size. And then we can display it by just typing p again at the bottom. And we can go ahead and run this. Okay, so this question can be converted into what's the probability that more than 24% of these participants have more experience than she does. Okay, so now we can take these and actually put them into our normal distribution and answer this first question. Let's go ahead and go back to distraction and click on normal distribution. Okay, so when it asks for the mean here, what we are actually going to use is we're going to use some of these values that we calculated. When we're dealing with proportions, the mean that we're going to type in is 0.23, or this true proportion. And the standard deviation that we're going to use is actually the standard error that we calculated, or this one down here, this 0.03649. So let's go ahead and look at our distribution real quick. Notice it is centered at 23, and the standard deviation is this 0.036. Now this behaves just like any of these other normal distribution probabilities that we've been working on. So we can say, go ahead, compute the probability, and it says more than these 32 participants, and we'd need to put that in the proportional form, this sample proportion, as 0.2406. 0.2406. Now when we look at our graph, we actually have made a mistake because it shaded the less than side. And so we need to make sure that we have clicked on the right probability statement. We want it to be greater than. And so the probability that more than 24.06% of the participants have more experience than she does is in fact this 0.386. Okay, next question. The competition at this cook-off is actually really stiff. In fact, it falls into the top 11%, where the other contestants are more experienced than Jocelyn. How many people are more experienced than her? Round up. Okay, so we need to figure out, okay, what is the proportion if we were in the top 11%? So this is a very stiff competition. There's a lot of really experienced competitors here. So what we are looking for is we need to do a quantile. So we're going to go ahead and click on Compute Quantile. And let's just go ahead and start off by typing in 0.11, our 11, and we want this cumulative, not from the middle. So the problem that we have here is this would actually be the bottom 11%. This would actually be an easy competition. So when we want to be in the top 11%, we need to make sure that we do 1 minus that 11, which is going to be 0.89. Now we hit enter, and it gives us 0.275. The problem is that's the proportion of people who have more experience than she does, and we want the number who have more experience than she does. All right, so remember this 0.275. Let's go back to R. So in here, if we want to know the number of people who do more than she does, we'll do 0.275 multiplied by our sample size. And if we run that, we're going to get this 36.58. We're going to round up, and that leads us to 37 people are more experienced than her. Okay, let's finish this off. Jocelyn actually performs best in competitions where only 18 to 28% are better than her. What is the likelihood that this occurs? So let's go back down. So now we need to find kind of the area between two values. We can do this. Let's go ahead and click on our normal distribution stuff again. And we can figure out a probability between these two proportions. So if we type in this 0.18 and we go all the way to 0.28 and we say we're going between those two, the probability that this event is between 18% to 28% is 0.829, or roughly 83% of the time. She would be in these competitions where she does her best. So anyhow, that's how we can use the normal distribution in the central limit theorem cases where we are actually working with proportions. So we have to do a few checks to make sure that we actually can do it. And then we also need to calculate our standard error by using the true proportion and sample size. And then from there, we can go ahead and use this normal distribution in order to help answer these questions of these probability statements. So I hope that helps you out and that you can utilize the central limit theorem when we are working with proportions.